All right, guys, this is Ms. Hodges here again. I'm here to help you with working through forces and understanding Newton's second law specifically in this worksheet. Again, before you watch this video, you need to stop and work on it yourself to see how well you can do on your own. This is just meant to be a supplement. This is not meant to just give you the answers, but to try to help guide you through understanding what these answers are and how to solve them on your own. Again, I don't help with the test, so if you're having trouble with any of these concepts, I encourage you to go and speak to one of the physics teachers at school and see if they can help guide you through a little bit more detailed explanation of these concepts. So let's go ahead and get right into it. We're gonna first, what I like to do is make sure I highlight my equation so that I know what I'm working with and what I need to use in order to get the answers that I need. So velocity equals distance over time. Acceleration is the difference in velocity over time, or the change in velocity over time. The distance that an object travels is equal to 1/2 the acceleration of the object times the time square, and that's what we find here. This next one is not an equation, but a constant. This constant, gravitational acceleration constant, or it's acceleration due to gravity. It's a constant, meaning that it doesn't change. It's meant to represent, G is meant to represent the acceleration of a falling object under Earth's gravity. And then lastly, this last one is a equation. F net, that's the net force acted upon an object, is equal to the mass of that object times the acceleration the object is experiencing. So I like working through the equations because that's where most students typically have trouble. So we're going to I'm just going to talk through numbers 1 and 2 and 3, and then we'll work through number 4, 5, and 6 together. I think there's a second page actually. Yeah, there is. So we'll work through those other ones together. So let's get started. State Newton's second law of motion. Well, technically what Newton's second law of motion says is that the acceleration of an object, and don't forget that acceleration is the change in velocity, right? Acceleration is the change in velocity. I'll make it small. There we go. Change in velocity. That means the object is slowing up or slowing down or speeding up. The acceleration is equal to that. And that acceleration is due to all of the forces acting on that object divided by how much the object, divided by the mass of that object. All right. And what we can say is, or that technically speaking, it's that the acceleration of an object is inversely proportional to the mass and directly proportional to the acceleration. Sorry, inversely proportional to the mass and directly proportional to the force applied on it. Simply stated that if we apply a force to an object, that object will have a mass and an acceleration. If we can calculate the mass and acceleration of that object, we know the force that was applied. Okay, so Newton's second law of motion basically says that the applied force of an object is equal to its mass times the acceleration. Next, number 2, if the force of an object increases, then what is likely to happen to the mass of the object, or what is likely to happen to the acceleration of the object according to this law? Okay, so this is just basic, simple understanding of how these equations work. Just thinking about it though, if I push an object harder and the object weighs the same, what do I expect to happen to its acceleration? well, the harder I push, the faster I think it goes. And so that reasoning right there does hold, especially in light of the fact that if we say that F equals MA, then if our F increases and our M stays the same, then our A must increase proportionally. Okay? Or, better yet, if we write it like this, A is equal to F over M, and this is just another mathematical way of writing it out, that if our F increases and our M stays the same, that means our number in the numerator increases. That means our M can go into F more times, and that means our A will increase. Okay, so as force increases, so does acceleration. If the force on an object remains the same, so if our force remains constant, or F doesn't change, however, the mass of the object increases, what is likely to happen to the acceleration of the object? So again, one of those logical ways of thinking about this, if I have an object and I'm pushing on it, and then all of a sudden it doubles in size, does the object move just as fast? Does it increase in speed, or does it slow down? Well, if it's bigger, it probably weighs more, which means it's harder to push, which means it's not moving as fast. And so that reasoning follows. But so does the equation, right? So if we have an F, and our F doesn't change, right? Our answer here doesn't change, and we have a mass and we have an acceleration. Well, if F doesn't change and M increases, what would have to happen to A? Our acceleration would have to decrease in order for F to stay the same, and it would have to decrease proportionally. Better yet, if we're looking at A equals F over M, if our F doesn't increase, but our mass increases a lot, our denominator gets bigger. Any number in the denominator, as it gets bigger, makes the answer, the other side of the equation has to decrease and has to decrease in magnitude. Okay, because M, as it gets bigger, can go into F fewer times, so our A would have to get smaller. So that was a long explanation for 1, 2, and 3. Hopefully numbers 4, 5, and 6 doesn't take as long to get through, and I'll try to get through it pretty quickly so you're not watching a 20-minute video. All right, so again, we're going to annotate. We always annotate. I strongly suggest you do this every time. A 15-kilogram car needs to accelerate at 4.5 meters per second. What is the force required? All right, so again, if I have a mass, and my mass is 1,500 kilograms, I know that I need to have an acceleration of 4.5 meters per second square, and I know I'm looking for a force. Let's figure out which equation we should use. We have an M, an A, and an F. Which equation up here do you think, and I say up here, which equation up here do you think I should use? It should contain an M, an A, and an F. And you would be right. Right? The formula should be F equals MA. That's what I'm looking for. So again, this is really plug and chug type of stuff. So F equals, let's see, 1,500 kilograms times 4.5. See, F, the force necessary my bell is going to ring here pretty soon, guys, so I'm going to have to stop this video. But hopefully I won't forget where I'm at by the time I pick it back up. So 1,500 times 4.5, 6,500. My force that I need to push it at would be 6,750 newtons. Boom. Easy peasy, lemon squeezy. Look at that. All right. Let's see if I can get one more in here. And I'm just going to walk through this again. I'm not going to explain it. I'm just going to walk through it. Hopefully you'll be able to pick it up as we go. So a force of the propeller is of a 0.75 kilogram propeller, 17 newtons. What's the acceleration? All right, I'm given a mass, 0.75 kilograms. I'm given a force, which is 17 newtons. I'm looking for acceleration. Again, I'm going to use F equals ma. I'm given an F, 17 equals m, 0.75. I'm looking for a. Just going to divide 0.75 by both sides. 17 divided by 0.75, 22.67. So that my A is equal to 22.67 meters per second square. And that's my acceleration. All right, guys, well, that's my bell. So I'll try to pick up from here on when I get back. Thanks. All right, let's pick up where we left off. So number 6 says 2.2 kilogram book sits on a table. What is the force of gravity acting on it? So I know I'm gonna click my pen here. A 2.2 kilogram book is sitting on a table, and I'm looking for the force due to gravity. So I know a couple of pieces of information. First, I know that the mass of the book is 2.2 kilograms. That's the mass. And I know that I'm looking for the force due to gravity. So the force due to gravity. And I know one more piece of information that's not given in the question, but it is assumed based on the information we're given. I know if I'm looking for the force of gravity, then I know that the acceleration of gravity is a constant that I've been given. And I'm going to look at this equation, or this constant right here, this gravitational constant of 9.8 meters per second square. And so I'm going to say that's the acceleration due to gravity. And if that's the acceleration due to gravity, then that acceleration is applied to my book sitting on the table. So that's 9.8 meters per second squared. And because I'm only looking for the magnitude, not necessarily the direction, I'm just going to take the absolute value of that constant, which is 9.8, not negative 9.8. Again, I'm just looking for the magnitude of the force. Because we know it's going in the downward direction. So again, I have a mass, an acceleration, a force. The equation that I'm going to use is my net force equation, which is F net is equal to mass times acceleration. I know I'm looking for the force. I've given my mass, which is 2.2 kilograms. That's 2. I can write with my pen, 2.2. And my acceleration is 9.8 meters per second square. Just gonna multiply those two. I'm gonna assume it's 22 or a little less than 22.
Has ended and all students should be reporting back to class. Again, the dance
2.2
meeting has ended
times
and the students should be
9.8
reporting back to
equals
class.
21.56. So the force due to gravity acting on the book is 21.56 newtons. All right, and so that's how we solve that first page. I'm going to pick up on the next page here on part 2. All right, we're back. And now we're going to solve question number 7. It says that a 7-kilogram wagon was pushed with some rightward force, causing an initial constant velocity. The person stops pushing the cart, and then it experiences a force of friction 45 newtons to the left. What will its accelerate? What will be its acceleration? There's a lot of stuff going on in this question, but first we're going to annotate the question, I'm going to break it down, and then we should be able to answer this question. All right, so I know that I'm given 7 kilograms is pushed with some rightward force. All right, so a rightward force. And this is some rightward force, so we don't know what that force is. Some applied force. There we go. Causing an initial constant velocity. So what does my constant velocity say? What does constant velocity mean? A constant velocity means that my acceleration is equal to 0. I don't have an acceleration. It's not speeding up or slowing down. Okay. The person stops pushing the cart, and then it experiences a force of friction of 45 newtons to the left. What will be its acceleration? So, first we need to know, first we have a little bit of information here that we automatically know. First, we know that if the object was initially experiencing a force, well, first we'll write some things down. First, we know that the mass is 7 kilograms. And we know that the force of friction to the left, so that's the force of friction to the left, is 45 newtons. Right, that means it's opposing the applied force, going the other direction. And so what I'm looking for is the acceleration. So obviously I'm going to be using the force is equal to mass times acceleration equation, but how do I know what the question is asking me? Well, it's pretty simple actually. I know that if it's that the sum of all of my forces, I know that my F net is the sum of all of my forces, and this symbol is the sum of all of my forces, so that I know that if I have two forces that are opposing each other, then I should be able to calculate my net force based on those two forces. I'm also given another piece of information. I know that at one point in time, my acceleration was 0, which means that I had a net force of 0, meaning that if I have a frictional force of 45, then I must have an opposing force of 45, so that my net force is 0. And if I know that my opposing force is 45 newtons, then all I would have to do is plug in my equation. F is equal to ma if I want to find my acceleration. 45 is equal to 7 times a. Right, 7a. I'm looking for the actual acceleration of friction, acceleration of friction in the opposite direction or going to the left. And the easiest way for me to do that is to divide both sides by 7, so I can get my acceleration by itself on the left side of the equation. I'm going to divide 45 by 7. I should get something like 7.5. Ish. 45 divided by 7. Oh, I'm sorry, 6.5, but 6.42. 6.4, and I'm going to round up to 3 meters per second square. And that's the answer I'm looking for.